Quartic function, general form of the quartic function fx equals to the x power of 4 plus bx cubed plus cx squared plus dx plus e. And before you sketch the graph of the quartic function, first here you find the stationary point of the function. Okay, first you find the stationary point of the quartic function. You let the first derivative of the quartic function here equal to 0, and you find the value of x here. So the stationary point of the function here exists when the first derivative here equal to the 0. Yeah. And question B, find the inflection point of the quartic function. F double prime of x here equal to 0, and you find the inflection point. Yeah, so here the point of inflection exists. Okay, question B. And C, you find the x-intercept of the function. Okay, so you find the x-intercept of the function. You let y here equal to the 0, and find the value of x. And y-intercept of the function, x here equal to the 0, and you find the value of y. And last here you sketch the graph of the quartic function. Okay. Okay, graph of the quartic function. First you check the coefficient of the quartic function here. Yeah. First the value of a, you check the coefficient. If a here greater than 0, yeah, or a positive value, so the graph of the quartic function, from the left here, graph concave up, concave downwards, and concave up. Yeah. First shape of the quartic function, this one, first function, number 1. Number 2, when the coefficient of the quartic function here less than 0, or here negative, so graph here from the left, concave downwards, concave up, and concave downwards. Yeah. So the first graph here, 2 relative minimum point and 1 relative maximum point, and the second graph here, 1 relative minimums and 2 relatives maximum point. Yeah. Okay, question 12. Sketch the graph of the following quartic function. Y equals to the 2x power 4 minus 8x squared. Okay, step 1. You find the stationary point of the quartic function. Okay, given the quartic function y here equals to the 2x power 4 minus 8x squared, so you find the first derivative of the quartic function equals to the 8x cubed minus 16x. Yeah, and you let the first derivative here equal to 0, and you find the stationary point of the quartic function. Okay, 8x cubed minus 16x equal to 0, and you move out the 8x times x squared minus 2 and equal to the 0 here. Yeah, and the first value of x here equal to 0, and x here equals to the plus minus 2. Okay, so 3 value of x. Okay, and first value of x here equal to 0, and you find the coordinates of the stationary point. So you substitute 0 here into the function. Y equals to the 2x power 4 minus at x squared. So y here equal to 0, and the first point here at the origin. X here equal to 0 and y here equal to 0. Yeah, this one the first point. Okay, and second, x here equals to the set 2, and you substitute into the function, and the value of y here equals to the negative at, and the point here at the set 2 negative at, and number 3, x here equals to the negative set 2, and you find the value of y here equals to the negative at. Yeah, so answer here negative set 2 negative at. Okay, step 1, you find the stationary point of the quartic function. Okay, step 2, you find the relative extremum point using the second derivative test. Okay, so you find the second derivative test. So first derivative here equals to the at x squared minus 16x. So at x cubed minus 16x, and you find the first derivative, second derivative of the function. Yeah, second derivative here equals to the 24x squared minus 16. And the first value of x here equals to the negative 2. Yeah, so you substitute into the second derivative, and answer here equals to the 32. Yeah, or here greater than 0. So the sign here negative. Okay, so sign here positive, and conclusion the relative maximum point relatives sign here positive, so relatives minimum point at the negative set 2 negative at. So this one correction. Okay, first point and the second point. Okay, second point, the value of x here equal to the 0, and you substitute into the second derivative, and answer here equals to the negative 16. Yeah, so the sign of the second derivative here negative, and here the relatives maximum point. Okay, so relative maximum point here at the origin at the 0 0. Yeah, and the third point x here equals to the set 2, and then the second derivative here equals to the 32 here the positive sign, and here the relatives minimum point. So the relative minimum point here exists at the set 2 negative at. Yeah, or second option, you can draw the table of the first derivative. Okay, our second method to find the relative extremum point using the first derivative test. So you draw the table of the shape of tangent. So the first value here, x equal to 0, so table shape of tangent increase, horizontal decrease, so this one the relative maximum point, okay, so at the origin. And the second point, x here equals to the Z2 decrease, horizontal increase, so here the relative minimum point. And the third point here, negative Z2 decrease, horizontal increase, so here the relative minimum point, okay. Okay, so you can choose first method using the second derivative test, or using the second method, first derivative test, to find the relative extremum point. Yeah. Okay. Step 3. You find the inflection point of the function. Okay, first derivative of the function here equals to the at x cubed minus 16x, and here the second derivative 24x squared minus 16. Yeah. So you let the first derivative here equal to the 0, so the inflection point here exists when the second derivative equal to the 0. So 24x squared minus 16 equal to 0, and x squared here equals to the 2 over 3. Yeah, x here equals to the plus minus 2 over 3, or answer you here, x equals to the plus minus 0.816. Yeah. You can write down the answer here in a decimal form, at least 3 decimal places, or you can write down the answer here in a set form. Yeah, this one in a set form, and here in a decimal places. Yeah, at least 3 decimal places. Yeah, 0.816. Okay, and you find the coordinates of the inflection point. So the first point here, x equals to the 0.816, and you substitute into the Quartic function. Yeah, 2x power 4 minus 8x squared. So answer here negative 4.440, at least 3 decimal places. So the first point here, 0.816, negative 4.440. Yeah. And the second point, when x here equals to the negative 816, you substitute, and answer here equals to the negative 4.440. Yeah. So Quartic function, first inflection point here, and here the second inflection point. Okay, and then step 4, you find you draw the table of concavity. Okay, so first here you check the domain of the quadratic function, domain of quadratic function, domain of the cubic function, all the real numbers. Okay, negative to the positive infinity, and you check the inflection point. The first value of x here equals to the 0.816. Okay, so first one here negative 0.816 and second positive 0.816. Yeah. So here from the left of the function, here start from the negative infinity. So start from the left here, negative infinity. First value from the left negative 0.816, and the second value here positive 0.816. Yeah. So here the first interval between negative infinity negative 0.816. So you put the first interval here. And the second interval between negative 0.816 to the positive 0.816. And the third interval here between positive 0.816 to the positive infinity. Yeah. So three interval of the quartic function here. If you compare with the cubic function only two intervals. Yeah. Okay, first first value you check here. Okay, so from the left, the nearest value negative 1, and you substitute into the second derivative of the quartic function. Yeah. So the sign of the second derivative here equals to the positive sign. Okay. And the second value between negative 0.816 positive 0.816. The nearest value here, you put the you pick the 0 and you substitute into the second derivative. So sign here negative, and between 0.816 to the positive infinity, the nearest value here equals to 1, and the sign here equals to the positive. Yeah. So the concavity of the function, positive value, the graph here concave upwards, CU, and negative concave downwards, CD, and here positive concave upwards. Yeah. If you draw the concavity of the function, first here graph concave up, and after negative 0.816 graph here concave downwards, and after positive 0.816 graph here concave up. Yeah. So you combine the three shape here. So graph here concave up, concave down, and concave upwards. Yeah. Okay. And the relatives maximum, relatives inflection point here exists. Here negative 0.816, and here the first second inflection point. Yeah. So the maximum at the origin at the 0, 0, and this one the relatives minimum point. Yeah. Okay, step 4, you find the table of concavity, and step 5. Okay, step 5, you find the intercepts of the cubic function, quartic function. Okay, so you find the intercept of the function. This one you just use your calculator. So the value of x here equal to 0, and you find the value of y. This intercept exists at the origin 0 0, and here your homework. Okay, so this one your homeworks. Okay, you just check your calculator. Okay, so answer here, first value from the left negative, and the second value of intercept here positive. Okay. Okay, in step 6, you draw the graph of the quartic function. Okay, so you draw the graph of the quartic function. So you can check the shape of the quartic function. You check on the table of concavity. So graph here, from the left, concave ups and concave downwards and concave up. Yeah, you check the step 4. Yeah. So from the left here, graph from the left negative infinity to the negative 2 graph here concave up. Okay, so you label first here, you label the relative maximum point at the origin at the 0 0, and you label the relative minimum point negative set 2 negative h and positive set 2 negative h, and the inflection point, first inflection point here negative 0.816, negative 4.44, and negative positive 0.816, negative 4.44. Yeah, and here you label the x-intercept of the function. Okay, you check calculator, and you label the graph here. Okay, so you label the graphs. Y here equals to the 2x power 4 minus at x squared. Yeah. Okay, settle graph of the quartic function. Okay, method to before you sketch the graph of the quartic function. Yeah. First here you find the stationary point of the quartic function. This one you find the first derivative of the function dy over dx. Yeah. So you let the dy over dx here equal to the 0. Yeah. And second here you find the relative extremum point, the relative maximum or the relative minimum point using the first derivative test or using the second derivative test. Yeah, this one the relative maximum. Okay, step 2 and step 3 inflection point. You let the second derivative equal to 0 and you find the coordinates of the stationary point. You find the value of x and value of y. And step 4 here, the table of concavity. You check the graph here, concave up or concave downwards. And step 5, you find the intercepts of the function, x-intercepts and y-intercepts of the function. Yeah. And last here, you draw the graph of the quartic function. Graph of the quartic function. First, the shape of the function here may be when a here greater than 0, you just check the shape of the function. Okay. 2 minimum point, 1 maximum. And the second, when the coefficient of the a here less than 0, so the 2 maximum and 1 minimum point. Yeah, very simple. Yeah.